Well, let's hope this works. Good afternoon, everyone. My name is Jose Luis. Most of you know me already. Several of you have expressed individual interest in getting to know Machina and the work that I've been doing lately with robots and how this can help each one of you in your particular projects, right? So I thought of organizing this. I'm sorry it was a Friday afternoon, but it was as soon as I can make it. We can probably go for beers all together after this. Since many of you have like different levels of expertise and interest, I do not want to make like a very thorough nor very comprehensive workshop. I will try to make something a bit more lightweight and more fun for you to get a glimpse of what Machina can make for you and what are the cool things that it features and how it's different from other tools that are out there. And then if you guys are even more interested, then we can cater for each one of your projects and we can look how you can take it further, all right? Maybe a quick round of introductions, your name and where you're coming from, just for the sake of the group. You want to start? I run IK Studio. I'm K, in particular. All right, cool. Okay, so real quick, before I get into explaining any of this, I want you guys to be set up with Robot Studio and ready to start like talking to the robot, all right? So we're gonna do that right now together. We're going to open Robot Studio, and I wanna do this with you because sometimes there's a couple details that are missing and they lead to frustration, so that's why I wanna do it together. Then first thing we're gonna do is we're gonna create an empty controller. And if you get lost or anything, I'm recording this whole thing. So you can always watch it later. So don't be afraid, don't panic. We're gonna create a new solution with the robot controller. We're gonna call this whatever, like test with Machina with an IRB 1200, for example. It doesn't really matter. And then here, you're gonna choose which robot model you wanna work with. You would typically choose whatever is closest to what you have in your school, your practice, etc. right? For the sake of this workshop, I'm going to choose an IRB 1200 because it's like a mid-sized robot, and we have one of those downstairs that is very easy to use. So it's a good reference of frame. All right. So we're going to choose one of those, and I want you guys please to click on Customize Options. All right. We're going to hit Create, and then it's going to take some time to process. It's going to prompt you with a menu. And this is the menu that I wanted to access. This is a menu that allows us to customize what features this robot has. It's like with cars. You can choose extra features which lead to extra functionality, cool things, right? It is important, because we're going to be doing real-time robotics, it is important that the robot has what's called the PC interface, which means it's an option that allows the robot to communicate via TCP IP with other devices, right? If we don't have that in our virtual robot or in the physical robot that we have somewhere, you won't be able to do real-time robots at all with ABB robots, all right? So here, we're gonna go to communication and choose PC interface, and then we're just gonna start this one, all right? We're choosing Robot Studio because we wanna test things out before doing anything in a physical robot, and it just so happens that Robot Studio as a simulation environment is by far the best thing I've ever encountered for industrial robots, all right? And since Machina, which is the platform that we're going to be using here, is, oops, this is not the one. What did I choose? Okay, I'm going to start over. I'm going to close this thing. I don't know what all right. And then, oh yeah, okay, so this one. And as I was saying, since Machina is a programming language that connects to many many different virtual and physical robots with the same language. If you try things and they work with ABB robots in Robot Studio, very, very likely they're going to work the same in any other brand of robot or with any other physical robot. All right? So here, I'm going to be prompt to choose this guy. All right? And that's it. We have a virtual simulation of a robot. And for all practical purposes, this robot that we have in our system, in our computer, is as if we were physically connected to a physical actual robot. All right? We can do TCP communication. We can do messaging, socketing with this guy as if we were connected to a physical one. That's why Robot Studio in particular is very good for these kind of real-time simulations. All right? Any questions so far? Okay, so then let's go back to the cool stuff. We're going to minimize this for a second, all right? And I'm going to prompt you guys to come here to the main website where with the repository of all things Machina, okay? The website is github.com/robotxmachina. And Machina is a project that I've been working on for the past year, year and a half. And it's like many other projects in this field. It's a framework of systems that allow you to customize, to control, and to program robots, right? There are many of those out there. And the special thing about Machina, the thing that makes it a bit different, is that it tries to focus a bit more on the real-time aspect of communication with robots, right? So most of the decisions that I made on how Machina behaves and how the language looked like is catered towards making it very immediate. All right? Many of you have probably 3D printed something in your life, right? 3D printing is a process where you basically make all the design, you model everything in a digital environment, you make all the slicings with your tools, with whatever other tools, and then out of that slicing, you create some kind of program, like G-code, for example. You put it on a file, stick it to a printer, and then you hit play. And then you hope that runs, right? That is not real time at all. That is, everything is pre-compiled, pre-processed, and once you start the actual fabrication part, you're done. You're out of the process, right? That is the paradigm. That is what kind of, that like textility, that decision making while making things is a little bit of what got lost with digital fabrication, and it's a little bit of what Machina is trying to bring back. The idea that instead of pre-canning everything, maybe we can talk to the robot and communicate back and forth while the robot is doing things. And hopefully, I will show an example of, or several examples of how to do that today. All right? So, if you are a power user, and you know how to code, and you know frameworks and stuff, then what you want to go for is for the main core library, which is written in C#, right? If you know Visual Studio, if you know how to code, but only a very subset of people know how to use those techniques. So that's why in this workshop, I'm not going to talk about that. I'm not going to talk about the core library at all, which is what everything else is built on. But what I'm going to show is some other tools that I've built on top of the core library, which are much easier to use, are much more intuitive, and connect to the typical tools that all of us designers use in our typical design workflows. All right? So the first one that I'm going to point you guys to is what's called the Machina Bridge. All right? And if we go into the repository, you're going to see that it's super, super bare bones, because literally I am developing this like every day. So it's still like very, very heavily in work in progress, right? If we go into the distribution folder, you can see that as I release versions, you will see zip files here popping up with like stable versions. I published today, like 3 hours ago, I published like 7.0 for you guys, right? And if you're like very adventurous and you want to risk your life, then you can always access the very, very last version in the nightly build with like all the bugs and like the latest features. But if you don't have a helmet, please do not do that, all right? So we're going to download today 0.7, which is you can download from here, or you can download from the link that I sent you in an email like 5 minutes ago, all right? If you download that, you should be able to unpack this folder. You will have a folder where you have a lot of executables, DLLs, and very likely if you're running Windows 10 and you double click on the main file, which is Machina Bridge here. If you're running Windows 6, it will give you an alert like, oh, you downloaded this from the internet, it's dangerous, blah, blah, blah. Well, if you don't trust me, then just you can leave right now. Otherwise, you can just like, oh, no, I would just want to run it anyway. And when you double click, you should be able to access, something like this should pop up, all right? Again, I pre-apologize. This is super, super bare bones. I'm working on this every day. And there's like a lot of things that are missing here and are popping as time as I have. Who's with me? Who is not with me? Are we all here? Matthias? All right. Are we good? Everybody? Okay, great. So what is this? This is a small application that I'm working on right now, as of today, which is powered by this core library that I told you about. What this application does is it connects to physical or virtual robots, like the one we have right now in Robot Studio. So we can input here the data, and then it gives you like a small console, like a command line, where you can input actions that you want the robot to execute right away. All right? So let's see how that works. What I'm going to do is I'm going to move this to the right, and I'm going to dock my Robot Studio on the left-hand side. And I'm going to go here, and I'm going to choose a couple of things. Here, you could write what name you want to give this robot. Here, you would choose the brand of robot that you would want to work with. Right now, we can only do ABB or Universal for real time. KUKA is coming sometime soon. And then here, you want to choose which kind of connection manager you're going to use. I'm not going to get into this right now, but just for the sake of this workshop, just type Machina, because Machina will basically take care of dealing with everything that means connecting to a robot for you. All right? So we're going to do this, and I'm going to hit connect. And if everything goes well, I should see things happening here in Robot Studio. And if I go to the Rapid tab, you can see that the button that I had here for executing programs is not a play button anymore, it's a stop button. Which means that right now, Machina did connect to the robot. It injected a special program called a driver. And now it executed this driver, which means that the robot right now is executing a program that is listening for instructions coming from this guy. All right? The robot is executing, but it's just listening for me to tell the robot to do things. All right? Any questions so far? All right. So now I'm gonna switch to this part. Because we are connected already, and because the robot is listening to me doing actions, now I can tell the robot to do things. So for example, here in the console, I can click on the console, and I can type Machina-style commands to make the robot do things. So for example, I can make the robot move in any XYZ direction. So let's say I want to make the robot move in the Y direction. And I want to make it move 100 millimeters. So what I'm going to do is I'm going to say move. I'm going to open parentheses, 0, 100, 0. I'm going to close parentheses, and I'm going to put a semicolon. If I do that, you can see that the robot just failed. The robot just failed because the robot is very close to a singularity. All right? So let's wrap up again. I'm going to disconnect from the robot, and then I'm going to do a small trick where here in the robot, I'm going to move it manually out of the singularity by going to modeling, right-click, join jog, and then just moving one of the joints. Okay, for example. All right? questions? How are we doing? Is moving? In parallels? Yeah. No? What is it not working for you? All right. All right. So, because you're doing this, like, what is it called? Where's the bridge? Okay. Can you connect?
That should work, right? Okay,
Yeah, that should work. All right.
I'll try.
Well, that's a very tiny console, man. Huh? Are you still there? Oh, shit.
Because
All
in
right.
the beginning you did something that I think we skipped, and now
Yeah.
every time we connect, it automatically closes Machina.
Okay,
So that
just
was-
close this guy. Yeah, because
Yes.
like,
Oh, because I think there was some.
just create a new one here and choose this one.
This one.
Yeah.
That was the-
Yeah,
there we
and
go.
communication and PC interface here. So you wanna. Yeah, that- yeah, what's going on with you? Maybe choose an location in your. Maybe choose like a non. Just like a non-map location. Yeah, well, then maybe. Yeah, Nono's having the same problem with parallels. I use it in parallels and it works fine. The 1200. 1200 is fine. Yeah, that one. Here, communication. All right. All right. So, okay, so let's rewind. We have the robot here. The robot is not on a singularity, meaning the robot is not facing forward like this. All right? So you can just move it somewhere like this. And then I'm going to connect again. As I connect, you can see that like stuff happens here, blah, 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 and the program just started, which means this is listening to Machina right now. And I can just, let's see if this works. I'm going to move 100 units in the y direction. And you can see that this thing is moving. All right. I'm going to wait until we're all here. Matthias. Good? Okay. One thing, because this is all in very, very early development, and because robots can be dangerous, one of the things that I did is like, if anything goes wrong with the bridge or with the communication or with the, everything is going to crash and it's going to give you a fatal error. You're going to have to restart again. That is on purpose, as of right now, because I don't want you to try to do things and just like have an error that you didn't realize and keep going. That may lead to bad things, all right? So that's why some of the people who've been using Machina for longer are a bit frustrated with the amount of errors, but it's a safety measure as of today, all right? Are we all here? All right, so let's start playing with the robot a little bit. So what can we do with the robot? As you can see, we have this command line here, and we can, any action that we tell the robot to do is going to do it right away, right? So for example, we can move in any XYZ direction. So for example, I'm going to move up. So I'm going to move 0, 0, and 100 up. Now I'm going to move In the X direction, 50 units, 0, 0. And now I'm going to move down. I'm going to move down a lot, like 300. And, oops, nope, I went too far up. And the position is out of reach. So what I'm going to do is I'm just going to disconnect, connect again. The program started, so now instead I'm going to move it down. So I'm going to move 0, 0, minus 300. Something that I want you to notice is that it's going to take some time to go down. So in the meantime, I can tell it to go in the Y direction. And you can see that Machina also takes care of queuing and buffering everything for you. So this action here is not going to execute until the robot is done going down. So the next action doesn't trigger until the previous one is done. Machina is taking care of that for you. So it manages all the queues, the buffering, giving priority to whoever's got it, right? Etc. This is a little slow. Perhaps we want to speed the robot up a little bit. So we can do speed 2, and then set it, for example, to 100 millimeters per second. If we do that, nothing happens in the robot, but the next action that we do is just going to go faster. So for example, I'm going to move up 200, and you're going to see that now the robot is moving much faster. Right? Questions? Matthias? Valentina? Good? Yeah. Linear TCP speed. The speed is always in relation to the tip of the robot. All right? Well, there's something wrong. Let's see. Yep. So right now, your robot is stopped. So let's disconnect here. And now try to connect again. Blah, blah, blah. Your program started.
Exactly.
Exactly.
Then I do
So
something.
now you can do 0, 0, minus 100, for example. And, sorry. There you
German
go.
keyboard.
Oof. And,
Program stop.
all right. So what is going on with you? Huh? All right. Why did it stop? Which robot studio are you running? Running a good one?
Not the
Uh-huh.
not the 32-bit, but the other one.
It's fine. It should work. All right. So let's open the bridge again. Maybe there was something in the queue. Man, you should get a new mouse.
Yes, totally. But here, here it actually works.
All right. All right. Machina connect. All right. So move 0, 0. Right.
You know,
That is-
just
yeah,
watch
but
if
that's
there's a kind of a bumper in the computer. But other things.
yeah, but that should not be a problem.
Uh-huh.
Are you? Do you have like the latest version of things?
Yeah.
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 Okay, I may have to look into that.
Okay. But that's something. Just transform to just a more kind of in-depth command for moving?
Yeah.
Or-
because you set location and orientation at the same time. All right. So now you should be able to move, actually. Matthias, you should be able to move. Simply move now. All right? So, things you can do. You can move in any direction, right? But you can also move to a location in Cartesian space, like X, Y, Z. The difference is, instead of saying move, which is a relative action, so from whatever you are, move a little bit in X, a little bit of Y. Instead of that, you type move to, where you're saying, I want whatever, I don't care where I am, I want to go to this new XYZ location. So for example, I'm going to do 300, 200, and 400. And if I set that, then the robot is going to go to those absolute coordinates in Cartesian space. All right? I can still move relative in any direction. I can move up. All right? Does that make sense? Okay. Other things that I can do. What do you think? What are the things do you think you would want to do with the robot? How would you want to move it? Simple moving is a bit boring. You want to do something else? We may want to rotate the tip of the robot, right? So for example, let's say we want to make this robot face me. If I was in the front, I would want to make the robot face me, right? What kind of rotation would that be? A rotation around what? If I wanted to make the robot like face me like this, about we can rotate around the y-axis, right? So it will be a rotation around the y-axis. So we can do that. We can rotate around the y-axis, and the y-axis we can represent it with the 3 coordinates of the y-axis, 0, 1, 0, right? 0, 1, 0. And then the rotation angle in degrees. So how much do we want to rotate this to make it face me? 90 degrees? For example, 90 degrees is good. Positive or negative 90? Positive? Who says positive? Who says negative? I'm sorry, okay. We use the right-hand rule, which means that if the vector is pointing like this is the positive direction of rotation. So if we rotate in 90, it would rotate inwards like this. So we want to rotate minus 90, all right? So minus 90, and then the robot, whoop. And we can still move it. So for example, 0, 30, 0. And because it's a relative motion, it keeps however the robot is, and it just moves in that direction. All right? What other things may we want to do? Well, we have an articulated arm, an industrial arm that has 6 degrees of freedom, right? And those 6 degrees of freedom mean that they have 6 axes, and each axis moves with whatever angle, right? So if we work with Cartesian coordinates, then it's the robot who figures out how much it has to rotate each one of the axes. That's the problem of inverse kinematics, right? But if we know how to do that, we can also set directly the value of this axis, right? So for example, home position, like this, like we started, is a very common position to start a program and to finish a program on. And for ABB robots, the angles for each one of those joints are 0, 0, 0, 0, 90, because it's facing down, and 0. So we can set that directly as well. So we can say, I'm going to set the axis of the robot to the absolute value, so axis 2, and then 0, 0, 0, 0, 90, and 0. And as I do that, Then the robot rotates back to its original position. All right? Home position. I don't know where this point is in space right now, but I know that it's always going to be this posture for the robot. All right? Okay, any questions? So, as I was saying, this is like super, super bare bones, and the console should give you like way more feedback on what's going on in the system. There will be more buttons here to stop, play things, to look at the queue of things that are happening. It's all in progress, all right? But one of the nice things about, well, let me put a pin on this one, all right? So if you use this application, the bridge, you can connect in real time, and you can stream, and you can move the robot, and you can see what's going on, right? But we may want to control the robot or to generate programs with the robot that are a bit more complex and that involve a lot more of geometry, form, 3D printing, pick and place operations, which if we did them by hand, it would be a little bit of a pain in the ass, right? So that's why this is like the main interface, the more direct one, the most tangible one, but we can use other interfaces that connect to our regular tools that we use. So for example, did you download the Machina for Grasshopper application? If you go to, again, if you go to the main repository, you can see that there's actually a lot of different tools that connect to different platforms. So there's a Machina that you can use in Grasshopper. There's Machina that you can use in Dynamo. There's Machina that you can use if you work with Python, if you work with processing, etc., etc. And all of them are open source. All of them are accessible. You can hack them. You can contribute to them. You can modify them. It's all very open. And you can download the latest version for Grasshopper. If you go to the Grasshopper project, you can download it from the distribution folder. And again, you can download the latest zip file, and it contains the library. Or you can go to Food for Rhino, and you will always be able to find here the latest version, the most up-to-date version, with the best features and with the less bugs, hopefully, right? If you download this package, you will be, if you download this package, you will be here. You can extract this, and what you will get is this here. And these are the files that you have to dump into your Grasshopper libraries folder. And this is a package with a lot of sample files that you can see, so that you can see how it works, okay? I'm going to give you a couple minutes to install this on your system if you haven't. I already have it in mind. And for those of you, you probably know already how to do this, but if you open Grasshopper and you go to special folders, you should be able to click on the components folder. In the components folder, this is where you should dump the 3 files that you downloaded from so these 3 files, you should paste them inside of the libraries folder. And remember, please, to right-click on those files and to unblock them, because you downloaded them from the internet, etc., etc. All right? You will, after doing that, you will have to restart Rhino and Grasshopper, both things. And if you do, you should, once you do, you should be able to have something like this. You should get a new tab here called Machina, and you should get a set of components like this. It does or it doesn't? I haven't tried it yet. It works? Yes. As you guys can see, I could totally use some help with the icons, which is also an open source project, just in case there's any designer here in the room. If you want to contribute to an open source project. Yeah, it doesn't block the files. Yeah. Are we all here? We got it? All right. So I'm just going to open some of the sample files. I'm going to go to the sample files, and I'm going to open the hello world, for example. Right? And the main idea when you create programs with Machina is that you create programs by defining what the robot wants to do, which actions you want the robot to execute, one after the other in sequence, like you would for a kitchen recipe. Right? Do this, now do that, do the same. It's very straightforward. So anything that the robot can do is called an action. And anything that's an action is in this large menu here. So like you saw before, for example, moving, rotating, setting the axis, or setting the external axis, changing the speed, popping up a message on the robot, waiting for an amount of time. All of those things right into the IOs, or, for example, extruding, setting the extrusion rate, setting the temperature, because Machina also works for 3D printers, right? So all those things are things that you can do. So basically, creating a program is just as simple as creating a list of actions and then doing whatever you do, whatever you want to do with them. So for example, here in this simple program, what I've done is I just created an action, which is display a message on the robot. And once I have that, what I can do is I can compile that list of actions for a robot that is an ABB robot. And what this component will give me is just like a really large program with the code in the native language for that robot that I can now right-click, save on a file, put it on the robot, and execute. So with Machina, you can also work in the classic mode. You can do offline programming. And you can do it for many different brands of robots. So for example, if you have a simple program that is going to draw a vertical. Let's see what this does. Here, I have a program where, let's see what this is doing. First, my program is just, as you guys can see, it's just a bunch of actions, one after the other, that I put together into a list. And the first thing is I'm going to display a message on the robot. I'm going to set the speed, and I'm setting the speed in absolute terms. Then I'm setting a plane, and then I'm moving and transforming to that plane in space. The plane is at 400, 200, and 500. Then I am rotating minus 90 degrees. I'm slowing down the robot. I'm moving up in the C direction, 250 units. I'm waiting 2.5 seconds, and then I'm setting the speed faster again, and I'm moving back home. I'm using the axis to go back home, right? If I put all of those together, I can create a program with all of these instructions, one after the other, and I can visualize. So those actions, if I represent them with text, I can read humanly like, hey, this is what the robot is going to be doing one after the other, right? And I could now, for example, compile this program for an ABB robot, right? And that program in ABB code, in rapid code, is going to look something like this. Blah, 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 move L, wait time, move apps.js, whatever this means. I don't even know, right? But I can right-click here. I can stream to my desktop, for example, simple path PRG. I can stream this. And now in my robot, I can just manually load it. I'm going to stop this. I'm going to load here. I'm going to load that program that I just, I'm going to load that program that I just outputted here. All right. I just loaded the program, and then I'm going to execute it. So I'm just going to hit play, and the robot is moving here. Now it's going to rotate minus 90 degrees. Now it's going to move up 250 units. Once it gets there, it's going to wait for 2.5 seconds. And now it's going to go back to home position. Yeah, absolutely. So what I did was, here in this panel, I right-click on Stream Destination so that I chose a file to write this text to. And I chose whatever name .prg. PRG is the program extension for Robot Studio files. All right? I saved that somewhere in my desktop. And then, in order to load this on the robot first, I did stop the program that was running, the connection with the bridge. I went to the Rapid tab here. I stopped the program. I extended Rapid. I extended T-Rob. I right-clicked here on T-Rob. And I hit Load Program. I did load this program. I went to my desktop here. On the right-hand side, I chose to choose the PRG format. Right? And I had the file here, so I loaded this file. And then after that, I just pressed play, start, and then the program executed. Yeah, right-click on T-Rob, load program. They're different. You can load modules, or you can load programs. The program is the whole thing. The module can be just like a part of a larger program. All right? Is that clear? Did you choose, when you load the program, did you choose the PRG format? No, when you load it.
Yeah, so sorry. So that PRG.
PRG, right? Save it. Okay, now right click here again. Right click, hit on stream. Stream contents. All right, you got it there. So now right click on there. Load program. Yeah. Here you choose this one. And you go to desktop. Yeah, and you don't have it. So let's try. And now stream contents, and now go to your Explorer and see if you have it here. You have it here. So you should be able to get it. Load program. There you go. And now it's loaded. And now you just press start. Now the thing is running for you. All right? No problem. All right. So you can use Machina like you use any other robotic framework to create offline programs, because actually creating offline programs is fairly easy. So for example, one of the nice things about Machina is that right now, the same program for doing all this stuff, we just compiled it for ABB robots in rapid code, right? But if instead you were working with KUKA, with a KUKA machine, you could just change the model of the robot, type KUKA here, and then we get the exact same program, but instead we get it in KUKA PRC code, right? Or if you're working with universal robots, you can just type here UR, and then you get the same program in UR script. If you're working with a 3D printer, for example, C morph, then you get the same code, but now you get G code. And you can also turn on and off having these kind of comments to help you. All right? Or if you just want to send this to a human being, you can just type human here, and then you can get like a human readable representation of this program, right? Or if you actually want to learn a bit more of how Machina works inside, you can also compile to Machina code. So I can type here Machina, and then this program will be computed to the exact same format that you would need to copy paste this in the console. And then just like, so if you want to learn what kind of commands and what kind of things you can type in the console, you can come first to Grasshopper, where you have icons and where you have like all these like tooltips that tell you what things you can do. And then the exact same program that you create here, you can compile it in Machina style, and you can copy paste it in the console and stream it in real time. All right? Any questions so far? All right. So this is all the offline boring part. But Machina can get a bit better once you start working with the real-time aspect. So let me wrap this back down and let me connect back. Actually, let me stop the recording for a second just in case. All right. So I'm going to go back here. We have the robot. I'm going to connect the bridge again. So I'm going to start. I'm going to connect the bridge. And it's not working because something is wrong. Oh, yeah, I need to set Machina here and connect. And now this is working. All right, we are connected again. Okay, so as I said before, there's a lot of things we can type in the console, all the actions, right? But one of the interesting things about this application as well is that when we were working in Machina like a couple months ago, we thought that if we kept it like this, like the way it was, we were only bound to people who knew how to write in C# or who had access to C# powered applications, or who were going to use Grasshopper or Dynamo, but nobody else. So actually, in collaboration with Nono, we had the idea of like perhaps creating an application that would expose some kind of like global protocol, standard protocol that all programming languages could access. And that's where the idea of the bridge came in. So one of the nice things about this application is that you have the console, you can type things in, all right? But at the same time, while you're running this application, the application in the back end is running what's called a WebSocket server. A WebSocket server is a server that accepts incoming connections from clients and that allows for exchange of messages. So for example, if you have an application that can run WebSockets, and pretty much all programming languages that I can think of have some form of WebSocket implementation or libraries. If you have any library or any framework that talks WebSockets, you can send messages to this bridge in the same format that you write them here in the console. All right? So for example, let's say I'm going to open again, I'm going to open this guy again, right? I'm going to remove from the example, I'm going to remove everything that is the compilation part. I don't care about this anymore. What I care is about taking these actions and being able to send them to the bridge and to execute them in the robot directly from Grasshopper without having to make a file, etc., etc. The way to do this is actually fairly simple. If you go to the bridge category, you can drop, the first thing you can drop is a connection component that has no icon. I'm going to say this again, it has no icon, it's very sad. And the connection component, what it does is it connects to the bridge. So you need to have the bridge running in the background, right? And then I'm going to plug here a connection, and I'm going to plug here a panel just to make sure that we know. And I'm going to double click here, and because the bridge is running in the back end, now my Grasshopper is connected in real time to the bridge. And the bridge will act as the middleman between Grasshopper and the robot. So what does that mean? It means that I can drop now, I can drop a send component, right? Which, and I'm going to plug in a couple panels here. I'm going to plug in a couple panels. To the send component, I can give it a connection to the bridge. I can give it a Boolean toggle, whether if I want to send things or not, and the list of actions that I want to send to the robot. Right? So right now, I have in my send component, I have a lot of actions connected. I have the connection to the bridge, and as soon as I hit true, look at what's going to happen. What's going to happen is that Grasshopper is going to send all of these actions, all of these instructions to the bridge, and then the bridge is going to send them in turn to the robot. Right? I did this once, but I can do it again. I can send the same program again, and I can send it again, and then it goes on the buffer, and it gets queued, and it will go into the robot whenever the time comes. Which means that right now, with this setup, I can take whatever program, and I can compile it to native code, or I can send it directly to be executed in the robot via the bridge. All right? Any questions? No, instructions are what Machina takes as code. So basically, an instruction is what you would write on the console. It's the same thing. So this is literally what Grasshopper sent to the bridge, and because it's Machina-style text, then this went into the robot and got executed. Say that again? Into Machina code? So back? No, not right now. But I could help you rewrite it with the human brain. Not automatically, not yet. All right? Okay. So this is good, and this is the first step into real-time robots. So being able to send instructions and have them executed on the fly, right? But if this was the only possibility, it would still be a little bit like the 3D printing thing, where like, yeah, well, now there's like some real-time communication, but it's still like one directional, right? Which is not great. So another thing that the whole Machina framework features is that there is always information coming back from the robot, all right? What does that mean? It means that not only can I send stuff to the robot, but I can listen to messages coming back from the robot as well. And therefore, if I listen to them, depending on what they tell me, I can react to those messages, right? So for example, how can I empower that? Well, here I have connection, I have sending, but I also have listening to the robot. What can I do here? Well, I can drop this component. That's so sad, it doesn't have an icon. And I can just connect it to the bridge. I can set auto update to be true, and I can set like a refresh interval of, for example, 33 milliseconds, which means how often this component is going to listen for these messages. All right? And here I'm going to connect, right? And you can see that the last message that came from the robot is something a bit hard to read because it's in JSON format, but it's basically the last message that I got from the robot was that there was an action that was completed, which was axis 2. But let me send a new batch of things again. I'm going to send this to the robot, and you can see that this is going to start changing as actions execute. You see how these messages are flipping? Because I'm getting, every time one of the actions that I sent to the robot executes, I'm getting a message back saying like, done, 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 done. It also tells me which one was done, and it also tells me how many are remaining. Right? If I want to see that better, I can connect, for example, I can connect a data recorder. I can connect a data recorder so that I can record everything that comes from this. So for example, I'm going to send another program again, right? And you can see all the messages that I'm getting. I'm getting action completed, I'm getting execution update with the position, the axis, the orientation, so I can know in pseudo real time where the robot is and when, where it is, how many actions are pending to be executed, etc. Right? However, this is like a little hard to read. This is not very human. So if I want to make that a little bit more human, I can use a couple components here that allow me to parse this and convert this into something that is a bit more grasshoppery, right? So for example, if I want to listen to messages like execution update, and literally these names are not great, I need to change them and make them a bit more understandable, but execution update is basically, it gives me information about the last, motion of the robot, right? So for example, I can connect here. I'm going to send a new package again, right? And this is telling me the last location of the robot. So you can see that I'm getting this plane. So that was when it moved here. I'm getting the rotation plane first, and then I get this plane when it got here. And then as it goes back, I get the axis of when it got back. Or something that I can do as well is I can say, well, I can connect an action completed. And action completed tells me what was the last action that was executed. So for example, it tells me what was the last action that was executed and how many are left. So for example, I'm going to send a new package, and you can see this is what got executed last, and this is how many are left. So you see, like a bunch of those got executed. Now it's going up. There's 4 left, and when it reaches here, is going to be move up. That's going to show up here, right? Yep. 3 left, then wait. 2 left, and then back home. And now it's setting the speed faster, and now it's going to go back home. It's going to show axis 2, and then 0 actions left. You cannot, what you can get from Machina right now is the theoretical speed. So the speed at which you set. But you can change it on the fly, right? Also, if your sensor was connected to the IOs, you could get those values from the IOs also from these packages that are coming back so that you could respond. Or something that you can do, for example, is you can do very simple logic with these values. So let's say for the remaining actions, I say, well, if the value of the remaining actions, is less than or equal to 0, right? This is going to give me a true value. So if I connect this true value to sending to the bridge, guess what happens? I've closed a loop where every time the robot runs out of actions and there's no actions left, it sends a new package of actions. Therefore, this robot is going to now start moving in a cycle forever until I disconnect this, or maybe until this becomes -1 and it will never comply. You see? Because now it's going to trigger, it's going to go 0. And just like a new batch was sent. Look at him. All right? Or you can do fancier things. So for example, in the samples files, I'm going to close this because otherwise it's going to go forever. I believe in the sample files, you have a file called Real-time 3D Printing, right? So I'm going to load that into, where is this? I'm going to load that into, so here I have, here. All right. So what do I have here? I have a bit more of a more complex file that has several parameters. So it takes an input, for example, this surface, right? And it says, this is like a 3D printing kind of thing, where what I'm doing is I'm taking a surface, I'm slicing it in horizontal layers, right? And then I'm defining how many points to go for each layer. And then I'm just going to send those to the robot to like execute. And I'm also using a little bit of, I'm preparing the robot, so I have, I'm creating a tool that is going to be the extruder. I'm turning the pin for extruding. I'm turning it on. Actually, this is not going to work with this robot because it doesn't have the IOs. Let me load a robot with actual, this one here. This one has an IO. Yep. And I'm going to need to connect this. All right. Nope. Well, something's not working. All right. Mm-hmm. All right, so now I'm connected. So I'm going to go back. And And what this program is doing is basically is creating a lot of target planes for the robot to move through, right? And then after that, I'm turning the I/O off, and then I'm going back home. All right. The only trick here is that I'm doing a little bit of data manipulation in Grasshopper, so that each one of those stages of programming is a different branch. So the first stage, preparing all the setup, is one block. Then the next layer is another block. Then the next layer is another block, etc., all the way until the very last block, where I turn the extruder off and I go back home, right? Why am I doing this? Because what I want is for this setup here to stream the 3D printing in real time, one layer at a time, in chunks, right? So let's see if that works. The bridge is on, so I'm going to connect to the bridge. I am connected here, and I'm going to give it the initial kick. So I'm going to start, up, and you guys can see that, what is the robot? Where's the robot? The robot is going there, right? And you can see that because I'm getting messages back from the robot, I can know where the robot is at any point during this 3D printing, right? But because that's happening in real time, I can also do things such as, for example, while this is printing, I'm going to increase the speed of print to 100, so that next layer that gets sent is going to be sent at 100 units. Does that make sense? Also, other things that I can do is, because layers are sent one at a time, I can change them while they're being sent. So for example, let's say that I take this surface and I change, for example, the shape of the surface. I'm going to deform this here. When the new layer gets sent, it's going to be sent with the new information, which means that at this point, now, the new layer is not going to use the old surface, but it's going to use the new surface. Let's see if that is true. You can see that, yeah, here, it went and it took the new surface. Yeah, and because what's happening is that every time here, somewhere, every time the remaining actions are 0, a new block is sent. So let's wait for that one to happen. So this is coming here. So around here, the new layer is going to be sent. Yeah, you see that just got sent. The new layer just got sent. But because the new layer is parametrically attached to the shape of the surface, it got sent with the updated surface. So for example, if I keep fooling around with this, I can move this here, right? And the new layers will just all right. Yep, that's pretty much what I had. An hour and 15 minutes. Not too boring. Not too bad for a Friday. All of this, again, is super under work in progress and heavy development. Things change very rapidly. I think it's getting in better shape than it was before. You guys have any questions? Well, I hope this gave you an overall idea of the kind of things that you can do with real-time robotics. This is more about breaking this old paradigm of like pre-doing everything and then like hopefully getting the robot to do it, but more like being responsive to what's going on. So with these kind of setups, you can more easily, for example, take sensor information from an Arduino, from something that's connected to the robot, and then respond with a movement that is catered to that information. You can do real-time things such as like move your hands with a Vive controller and send that to Grasshopper right away to send to the robot. You can perhaps respond to temperature changes, or if you're measuring your 3D print, and if it sags, perhaps you can also react to that. This opens a new set of possibilities that I find interesting, personally. So if you guys, I spend most of my time writing code. I barely get to use it myself, so if you guys feel like this could be useful for your project, I'd be more than happy. It's sort of my job, kind of, to help you get your projects forward. So if you're interested, just ping me, and I'll be happy to help you use it or to implement features that may help you in your particular project. All right? Okay. Well, thank you very much. Cool. Let's see what we printed. Well, the actual print would look something like this. This would totally not work, but well, you can implement like constraints and blah, 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 you know. Work in progress, work in progress. Right? But this is real-time 3D printing, guys. All right. Beer time. So one of the interns was going to develop the Python library. I'm not a huge Python fan myself. Sorry, I'm not a huge Python user, but I'm literally, it's just like writing something that has like a WebSocket server, connects with the WebSocket server, and then just like sends string messages with the Machina format. I have, for example, I have a JavaScript one and I have a processing one. It shouldn't take shouldn't take much to do a Python one. And actually, like, the way you know how to write Python, it would take you probably like a couple hours to do it yourself if you wanted to. I have an example. I sent you guys an example with, I'm going to close this somewhere. I sent you guys an example of a processing application, right? So where is that? Processing to the bridge, yeah. So basically, for example, same thing. Here with processing, you can see that I have this sketch here. The sketch has a WebSocket client, right? And it has this Machina robot, which is basically like a super, super simple class, right? That has a constructor that stores a socket, a WebSocket, and then just like a lot of methods that have the same format than the actual Machina API. So when you use this in processing, they just feel like Machina, but it's just like a really thin layer on top of the underlying, which is like sending a string with that format to the bridge, right? It's like, it's literally nothing. So, but if you run this, all the code here is just like making this UI fancy with the icons and blah, 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 but it's like, it's not complicated. So here, I think you can connect like this, and you connect to the bridge, right? And I think there was a tool here, so that's why it's doing this weird thing. But then you can go here, and then this, like this, right? And what this is doing is just sending like super simple move instructions to the robot. All right. Well, thank you, guys. No disappointment? Yes. I know you will. You're good at that. All right.